Okay. Let's get started. What numbers did we do? Okay. Tangents. 2. We started at 2?
10.
That makes much more sense. 10 through 28 evens. That sounds completely accurate. Number 10. No common tangent. Number 12. There is a common tangent, and you'd have lines coming off the top of it if you were to draw it. I feel like little children are breaking my stuff. I feel like I've whined about that for multiple days at this point. But it's okay. It's all right. At least you're listening to something. Number 14, yes, because 100 equals 100. Number 16 is also yes, because 80 equals 80. Number 18 is 8.5. 20 is 10.7. 22 is 1. 24 is 7 and 82 inches. Number 26 is 9 and 28 is a proof, which in the book at least has 8 steps. What questions do we have, kids?
24.
What? 24. All right, let's do 24. What? Wow, that's crazy. Oh. Where'd that box go? Nobody knows. I feel like I used to have more markers than that. Somebody steal some? Probably. Okay, something about like that in the picture. And it is circle W. And this whole length is 27 inches. This is 2x inches. This is 17 inches. This is 4 inches. Find the value of x and then find the perimeter. This is what it says. So, what should we do? Set 4 equal to 2x, he says. Is that legal? Yes, yes it is. Yeah, except. So this is one of those instances in this book where there are different additions, and almost certainly the later one corrected it, and it's supposed to be a 14 right here, which would make the answer key make sense. So it either says 14 or it says 4, but it's almost certainly supposed to say 14. Well, that's fine. You may have gotten the right answer, just not the right answer that the key is, right? You may, if it did be 4, then x would equal 2, and then the perimeter. How would we find the perimeter?
We gotta subtract 17 from 27.
Subtract 17 from 27 to find this one. This is 7, actually not to find this one. This one is 17, which means this one is 10, which means this one is 10, which makes that make even more sense being 14 instead of 4. Yeah, and then you add all that stuff up, right? So, you would have gotten what?
62.
You would have gotten 8 plus 20 is 28 plus 34.
Okay, well,
Yeah.
now I'm not confused anymore because I didn't do anything wrong.
Yeah. So with the correct numbers, this would be a 14. So it'd be 28 plus 20 is 48 plus 34, 60, whatever it is, 62, 82. Yeah, 82. Yeah, because 30 plus, yeah. Yeah. Okay, what other questions do we have?
Could we do 20?
Yeah, we could do 20. We could certainly do 20. Number 20.
What was the answer to?
10.7. That's what the book says. Okay. Circle. We've got tangent line. We've got a radius out there or something. Yeah, but to the radius to, I didn't maybe draw it long enough actually. So something like this. And it is labeled as X and 12 and 20. Okay. So, what can we do? And Reese, I don't want to hear from you, bro. Uh-huh.
So we could do x squared plus 20 squared is equal to x plus 12 squared.
Because this is also X. So X squared plus 20 squared. We just got to make sure we put the things in the right place, unlike what we did in class the other day. Equals.
You know where to put them?
Well, the hypotenuse is always C, right? So it's always the one across from the 90. Yeah, so the one, yeah, and it's always the one by itself. All right? Okay, so what's 20 squared?
400.
We've got to square that out. So x plus 12 times x plus 12. X times x is x squared. X times 12 is 12x. 12 times x is 12x. 12 times 12 is 144. Combine like terms, and we end up with x squared plus 24x plus 144. So then what would we do? Subtract the x squared, sounds good. Those cancel, leaving us with a 400 right here. 24x plus 144. Now what would we do?
Subtract 144.
Subtract 144. That cancels. 256. Now what would we do? Divide by 24. And you end up with x equals 32 thirds. Thirds, which is about 10.7. What other questions do we have? Okay, let's do the next one. So we learned last time what a tangent to a circle is. A tangent to a circle is a line that intersects a circle at one point. So what about a line that intersects a circle at 2 points? A line that intersects a circle at 2 points is called a secant. So crazy. So we've got a couple secants on there. These are both called secants. How is a secant different from a chord? Yeah, a secant is a line and a chord is just a line segment. Right? So the secants would contain chords, but they are not chords. This one is not you, and this one is you. Okay. First theorem about secants. If two secants or chords intersect in the interior of a circle, okay, then the measure of an angle formed is 1/2 of the sum of the measures of the arcs. We're going to write this as an example. This is going to be point A, B, CD. And we're going to label this as angle 1. And this is angle 2. So what this theorem says in this example, that it says that the measure of angle 1 equals 1/2 of the measures of the intercepted arc. So the measure of arc AB, the sum of those measures. So the measure of arc AB plus the, oops, that's not the right symbol, is it? Arc AB plus the measure of arc CD. Measure of angle 2 in this example equals 1/2 the measure of arc BC plus the measure of arc AD. So the interior angle equals half of the sum of the intercepted arcs. And we labeled this as angle 3 and this is angle 4. 3 we already know is the same as angle 1, right? Because it's vertical angles. Also, they're intercepting the same arcs. Make sense? Easy peasy. If you want to see a proof of that theorem, there's one sitting on page 741. Let's do some examples. Imagine that. Who'd have thunk it? On all of these, we're going to be solving for x. This first one is labeled like this. X degrees, 47 degrees, 116 degrees. This next one is labeled as an x degrees here, and 75 degrees and 55 degrees. This last one puts the x degrees right here, and 128 degrees here, and 154 degrees here. So, this very first one, how do we solve it? Add the two numbers together, divided by 2. This one's the easy one, right? X equals 1/2 of the sum of the intercepted one. So 116 plus 47. So what's 116 plus 47? So divide that and we get what? 81. 81.5 degrees. All right, now this one's a little bit more complicated. You hush. Okay, so why is this one more complicated?
Because it doesn't give us the opposite.
Yeah, because it's not this one, right? So what do we need to do? Find that one. So let's find that one. Well, we can even label this another thing. Let's label this as y. Why not? Right? So y would equal 1/2 of this sum, 55 plus 75. So y would equal, what's 55 plus 75? 130. What's half of 130?
15.
Definitely not 15. That doesn't make any sense.
Oh, 100. 65.
Okay, so that gives us that one. Now how are we going to find the one we actually want?
Well, 2y plus 2x equals 365.
That's true. 360, not 365. Or we could, they're also supplementary, right? Because it's a linear pair. So we could just subtract that from 180, right? Your way would work as well. It would, as long as you use 360 instead of 365. So x equals 115. Great. Now what about this one?
Do you plug it in the same way?
Pretty much, yeah. So what is going to go right here? 128. And then what's going to go here? I already did that. Sorry. X plus 154. And we solve for x. So what are we going to do?
Subtract.
Nah, you can't get there yet.
You have to
You could either distribute or, what's another way where you get rid of that 1/2?
divide.
Yep. How do you divide fractions? Yeah. So we can multiply 2 on both sides. What's 128 times 2?
256.
256. Now what? Subtract the 154. So x equals 102 degrees. All righty. Makes sense? Easy peasy? We're so talkative today. Let's learn some more theorems. Why did they do that? I guess they just wanted it in a pretty chart together. All right, let's learn another theorem and then another theorem in 3 parts. We'll do some examples and then you can leave after I tell you what your homework is. Okay. If a secant and a tangent intersect at the point of tangency, I hope you understand all the words that I just said, because you should at this point. If a secant and a tangent intersect at the point of tangent C. So here's our tangent intersecting right here, and here is our secant. They both intersect at the point of tangents. Oh shoot, a monkey. Intersect at the point of tangency. There's our secant. Then the measure of each angle formed is 1/2 the measure of its intercepted arc. So, I do it different than the one in the book, but that's fine. So angle 2, angle 1, the measure, let's see, we need some letters. Let's do A. Oh, yeah, because we need to be able to have major arc and minor arc. B, C. Secant and tangent intercept at the point of tangency, then the angle is 1/2 the measure of its intercepted arc. This one is really similar to the inscribed angle. It's the same idea, right? Same idea as that formula. So the measure of angle 1 in this example is 1/2 the measure of arc ABC. Why did I list 3 letters? We've talked about this for sure before. Why are there 3 letters there instead of 2 letters there? Because it's a major arc. We need that third one to say, oh, it's this big thing instead of just this little thing. So in this example, the measure of angle 2, is 1/2 the measure of arc AC. Right? Easy peasy. All right. One more theorem in 3 parts, because there are 3 cases. So we got 2, the first case is we have 2 secants intersecting the circle and meeting and intersecting outside the circle, so something like that. Second case is we have a tangent and a secant intersecting outside of the circle, so something like this. And the third case, which we've already kind of seen stuff about, is if we got 2 tangents that intersect outside the circle. So something like this. All right? Let's label these guys. This one we've got A, B, C. That's not how they did it, but that's fine. D and E. This one we've got critical points A, B, C, and D. Doesn't have as many points because there's not as many points interested, because this one only touches once, right? This one we have critical points A, B, and C. That's why they did the letters the way they did it, because then A, B, and C are the same on all 3, but that's fine. I didn't look at or think about that until later. All right? So, the way these are related, if 2 secants, a secant and a tangent, or if 2 tangents intersect in the exterior of the circle, so these 3 ways that could happen, then the measures of the angle formed is 1/2 the distance of the measure of the intercepted arcs. Okay? So, in this first one, let's label these all as angle 1. We'll save ourselves some time and trouble. How does that sound? So, the measure of angle, actually, they're all angle A, aren't they? Why would we need to do that? Why am I dumb? It's fine. The measure of angle A, there's only one angle there, so why not? Would equal 1/2 the difference of the measure of arc CD minus the measure of arc BE. Same idea here, right? The measure of angle A is 1/2 the measure of arc CD minus the measure of arc BD. And same idea here. Except we do need one more critical point, don't we? Throw a D on there. The measure of angle A on this one would equal 1/2 of the difference of the measure of arc BDC minus the measure of arc BC. So same idea, right? You don't have to memorize all those letters and all those things. You got an arc, if you've got a secant, some combination of secants and tangents that intercept outside the circle, then the measure of that little angle that they make is 1/2 of the difference between the two intercepted arcs. Great? Easy money? Let's do a couple examples. Couple of 4 examples. Sound good? Yes. I'm glad. Okay, so we're going to draw 4 circles, do 4 different examples. 1, 2, 3, and 4. Okay, so for the first one, we've got a tangent down here and a secant right here that intersect at the point of tangency right there. And it is 116 right here. And we've got H, J, L, and K. And we are trying to find the measure of JLK, arc JLK. This next one, we've got the same sort of a setup, but where our tangent is hanging out up here. And our secant is living like this.
What's that number right by J?
It's 116 degrees. And this one says, let's see, we've got QRST, Q, R, S, and T, I think, yes, sound correct. And we want to find the measure of arc RQS if the measure of QTS, arc,
Because R isn't on the circle.
oh, it's not arc. How about angle? If the measure of arc QTS is 238 degrees, and then the next two, we've got on this one, we have a tangent down at the bottom of it. Don't fall asleep on me. And we've got a secant. It's coming out here like that. And it is labeled RSTU, RST, and U. And this is 71 degrees. I believe it's the arc. And this is 179 degrees. Definitely the arc. This one, we've got a tangent hanging out right here. And then we've got a secant that's looking like this guy right there. And it is labeled XYZW, X, Y, Z, and W is over here. And this is labeled as 224 degrees. And the angle is 68 degrees. This one, we're supposed to find the measure of angle S. And this one, we're supposed to find the measure of arc XZ. Okay, come back over here. Measure of angle arc, JLK. How do we do that with this? Is it 1/2 of it? Go ahead, Reese.
You multiply the angle times 2.
Yeah, because the angle is 1/2 of the arc. So we're going the other way around, right? So the arc would be this times 2. So what is 2 times 116? 232 degrees. Easy peasy. So this one, the measure of arc, QTS, so this one is 238 degrees. So we have a problem, right? Because that doesn't have anything directly to do with the angle of the point of tangency, right? So what do we need to do to figure that out? Angle RQS, that is our ultimate goal, yes. Oh.
Other side, like,
Oh, yeah, you could. So you could do that. That's not how I was thinking to do it, but you could do it that way. Anybody got any other methods to do it?
So, could we divide 238 by 2 and then subtract it from 180?
Well, that's the same. That's not another way. That's the same way.
Yeah,
We could also do, it's not a different way. It's the same thing he was saying.
was he not saying subtract 238 from 60 and then 360 and then
No, that's what I was thinking.
Oh,
He was saying, no, he was saying what you're saying. Yeah, so you could do it either way. My brain jumps to this whole circle is 360 degrees, so to find this arc, it's 360 minus 238, right? And so you can do 360 minus 238 and then divide that by 2 and you'll have this angle, which is what we're looking for. Or you could, like they're saying, since this is tangent to this, you could find that one by dividing this by 2 and then subtract that from 180, and you'd also get that. I think you can do it either way. In my head, the 360 makes more sense, like you could come up with it easier. So what's 360 minus 238?
122.
So that is the arc. So to get from the arc back to the angle, what do we need to do? Divide by 2. So the measure of angle RQS would equal 61 degrees. Easy money. Right? The next one, how would we do it?
Would you take 179 minus 71 divided by 1 times 1/2?
Yeah, that's exactly what you do. 179 minus 71 is what?
108.
And then 108 divided by 2 is what?
54.
54 degrees. All right. This last one. Well, not quite, right? Because we know the angle, right? So we know that one, and we know the major arc.
We're just going to reverse the.
Yeah, we're just going to stick the X in here somewhere, right? So 68 equals 1/2 of 224 minus the measure of arc XZ, right? So now what?
Multiply by 2.
Multiply 2 on both sides. 68 times 2 is what? 136 equals 224 minus the measure of arc XZ. Now what would you do? Subtract 224. (136) minus 224 is what? Negative 88. And you divide by -1 to get rid of that, and we figure out the measure of arc XZ equals 88 degrees. Easy money? We'll find out when you do your homework. I know that I haven't put homework in Google Classroom in a long time, and I'm going to throw this out there, boys and ladies. If you're not doing your homework, you will do worse on the tests. Guaranteed. Which means your grade will go down. Guaranteed. So do your homework. We're more than halfway through April. We're almost there. We have about a month left, a little less than a month left. You can do it. Hang in there.
Is Unit 11 the last one?
We will get through probably part of Unit 11. Pages 746 through 747, numbers 8 through 32 evens. All right, I'm gonna just let you go. Have a good weekend. Go do your homework. Find somebody that loves you and give them a hug. Or if they're like your brother or something, at least a punch in the arm. It's the same thing, right?